So in this video, we're going to look at exponential functions that are not y equals ab to the t. So one of the first things you want to look at when you read a problem is you're searching for the percentage. Because if something is increasing or decreasing by a percentage, then we call it exponential. But what we have to realize is that there's actually three choices for formulas. So the formula we've already done, which was y equals ab to the t. And then what we're going to look at today is compound interest, which is this lovely big formula here. And then we'll finish up our notes today with y equals pert. So just because there's a percentage doesn't really tell you a whole lot. You're going to start looking for keywords. So the first word that jumps out at me in this problem is the word compounded. And then I note that there's an amount of time, annually, semi-annually, quarterly, or monthly. So those are kind of the keywords that let me know we're going to use the compound interest formula. So for P, we're going to be doing our initial value, which is 1,000. Now, unlike AB to the T, the letter B was a growth factor, so we had to use our rate to find the growth factor. With the two formulas we're going to do today, you don't. R is actually 12, or 0.12. So you can simply convert your rate to decimal form and we can use it as it is. If we're earning money, as we are in this case, then we'll use that as a positive 0.12. If we end up doing population, or if my account is losing money, we'll make that a negative 0.12. And then time, of course, is how many years in the future we want to go. So for this problem, that's going to be 3. So I'm going to show you just a couple different setups that you can look at. Now the first one is a little bit unique because my first one says annual. And if I'm compounding something annually, then I'm only doing that one time a year. So I'll show you kind of both options. So if I use the compound interest formula, I have my principal of 1,000, my rate, which is 0.12, and then the letter N stands for the number of times something would happen in a year. So if there's an annual event or an annual sale, we say that happens one time a year. So you'll notice there are two places to put an N, in the denominator as well as up in the exponent. So you'll notice in each example I do that these are going to match. And then essentially you're going to just type that into your calculator. What I want you to notice really quick though is that inside those parentheses, 0.12 divided by 1 is still just 0.12, and 1 plus 0.12 is 1.12. So normally when we use this formula, we'll just type it in the calculator as it is. But I want you to see that in the event that you do something simply one time a year, that actually is your AB to the T formula, where we have 1.12 as our growth factor. So what you'll notice about this formula is that with AB to the T that we did before, we had to physically add the 1 ourselves, or in other words, add the 100. But not for this formula. For this formula, that 100% is built in, which is why we can just use the 0.12. So whichever way you like it, if you like the AB to the T form, or if you like the compound interest formula, they would both give you the same answer, which is 1404.93. And of course, for money, we'll round to 2 decimal places. Okay. So for semi-annual, I'm going to use an N value of 2. And then you'll notice I'm using the same initial information. So I have $1,000, still growing at 12%. But when it's semi-annual, they're going to pay me that interest in 2 payments. So it's not like I'm getting double my money. I'm still going to get 12%, but they're going to pay me maybe a little bit in July and then maybe a little bit more in December. So they're spreading my interest payments in 2 parts. So again, you're going to put 2 in your denominator. You also have 2 up in the exponent. And let's look at what that looks like in the calculator just to make sure we're typing it in correctly. Okay, so to just point out 2 key things. So we have our 1,000, and then we have 1 plus r over n. And what I want you to notice is I only have one set of parentheses there. One set of parentheses, 1 plus r over n, and then close parentheses. Now we want all of that to be raised to the 2 times 3 power. Now of course 2 times 3 is 6, you could just type in 6. But if you are going to type in 2 times 3, you're going to need an extra set of parentheses there so that the n and the t will both be up in the exponent. And if we do that correctly, then we should get our answer. And so in this case, we get 1,418 and 52 cents. So really, you're just going to kind of repeat that a few more times with some various n values. Okay, so if something happens quarterly, then we say that that happens 4 times a year. So you're simply just replacing in the equation the n value with a 4, and that comes out to 1425. If something is happening monthly, we're going to use an n value of 12, and that is going to come out to 1430.77. If you want to try one on your own, you could hit pause right now and then come back and check your answer. And if you're ready to check for daily, we would use n equals 365, substitute that in for my n value, and that comes out to 1433. So it's fairly obvious when you do this back to back that the more often the bank is willing to pay you your interest during the year, in the long run, you end up a little bit better off. We have a little bit more money. And so what I want us to think about is, so if the bank is going to pay us a little bit of interest daily, then we would consider that 365 times a year. But what if they were to give us interest hourly? So that means they would be paying us interest 8,760 times in 1 year. And then we could get even more specific and say, but what if they were to recalculate my interest on the minute? Then that would happen 525,600 times per year. Okay, so what this is leading us to is, what if you're told that they're going to compound your interest continuously? So we run into this problem where there is no such n value that would essentially represent all the time. So continuously means every second, every millisecond of every day. And so when we see the word continuously, we're going to have to stop using our compound interest formula, and we're going to actually switch to another situation that we're going to just call PERT. And we will look at that in another video.